what is the change in wavelength as it moves from air into water. So it travels at this speed normally in air and at this speed in water. And the frequency, the frequency is going to remain the same because that just depends on the source where the light is coming from. That doesn't change. So so one way of doing this is just finding the wavelength in air and the wavelength in water and just finding the difference. So we know that the change in wavelength is the wavelength after minus the wavelength before. So the wavelength after is just going to be the wavelength in water. So V is equal to F lambda, and lambda is equal to V upon F. So the lambda after, or actually let's call this the lambda water, because it makes more sense since we're dealing with that wavelength in water. So same thing, it doesn't matter what you call it. So that's the wave speed divided by the frequency. So that's 3 times 10 to the power 8 divided by its, oh no, sorry, what is its speed in water? This is its speed in water. So that's 2.3 times 10 to the power 8 divided by its frequency, 7 times 10 to the power 7, which is so that's about 3.286. I'm just going to round it off. Meters. And this corresponds to the wavelength after when it's in water. And so the wavelength before, when it's in air, that's equal to its speed in air divided by its frequency. And what is its speed in air? That is 3 times 10 to the power of 8 meters per second. So that's just 3 times 10 to the power of 8 divided by the frequency, 7 times 10 to the power of 7. Let's work that out. That comes out to be approximately 4.286. I'm going to round that off as well. So this is your wavelength before when it was in air. So the difference, the change in wavelength, delta just is a symbol of change. It just means change in something. So you don't have to worry too much about that. So the change in wavelength is going to be that final wavelength in water minus the wavelength in air. The wavelength in water we found out to be 3.286, and the wavelength in air was 4.286. So that comes out to be -1. So -1 meter. So that's the answer. Oh, I just noticed they've given us data here for the speed of sound. Oh, they even told you the value of 1 kilohertz. I did not see that. That's useful. FM radio stations are broadcast in megahertz. So 95.8 FM is really 95.8 megahertz. Given that radio waves travel at the speed of light, use the value for the speed of light calculated earlier to find the wavelength of a radio station of your choice. So let's take 104.4, which is 104.4 megahertz, and we're gonna find its wavelength. So the wavelength is its velocity over the frequency. So that's 3 times 10 to the power of 8 divided by, and 1 megahertz is 1 million hertz. So I'm gonna write that as 10 to the power of 6. It's too big to fit in the space. So that's 104.4 times 10 to the power of 6. Let's see what that is. So that comes out to be 2.87. I'm just going to round that off to. Actually, I'll just leave it as 2.87. Maybe 2.874. This lambda represents the wavelength. And that's about it.